All right, so you guys are gonna graph these functions. I'm gonna do the same, okay? We'll make sure we don't have any technical difficulties. I think we all learned last year they happen when you use a lot of technology, right? Yes. All right.
I can't schedule on the board. Is it period 1/2?
Yeah. So right now is period 1 because we're only doing odds today. Yeah. And I'm going to draw lots of points for my lines because I'm not good at drawing straight lines. You guys will see, and you probably already saw based on what we did previously. All right, so these are my 3 lines. I'll zoom into each one so you guys can kind of see. I started with a y-intercept of 1 and used the slope of 2 to go up 2 over 1 from that point and create that first graph. Okay? Are we all good with that first graph? Now the directions below this say that in that first graph, they want us to highlight the portion where the domain is that x is less than 1. Now you can just make it darker with your pencil or anything like that. But basically, we want to think about where is x equal to 1, and that's here. That means this is like our boundary right here. And if we highlight the portion of the line where we're only highlighting the points on the line where the x values are less than 1, those would be on the left side of that. Kind of like Amy's trip, right? But in this line, I only want the portion of it where x is less than 1. So is everybody okay with 2 things? Number 1, can I graph a line? Do I remember how to do that? Okay. Number 2, are you guys okay with what I highlighted by the description below? That what I highlighted matches with saying I only want the portion that's in the domain where x is less than 1. Any questions about that first? So the graph or why I highlighted the part that I did again? All right, so our second graph, my y-intercept was 3.5, and I just graphed them this way because they were written in slope-intercept form, right? So they're handing me the y-intercept and the slope, so I'm trying to use those pieces of info. So I started at 3.5, and the slope was negative. So I need one movement to be negative. So I can go up, that's a positive, but then to the left 2, or I can go down 1, but then to the right 2, and that's creating the linear function that you see up there. The instructions given for that are to highlight the portion that's in the domain where 1 is less than or equal to x, which is less than 4. So in my head, I'm thinking, okay, where is x equal to 1? Where is x equal to 4? I think I figured those out, okay. And I only want the portion of the line where if I wrote out the points that were on the line, the points would have x values between 1 and 4. And so that would only be this portion in here. Okay? So is everybody okay with how I got the graph for graph number 2 up here? And is everybody okay with why this little sentence about in graph number 2, what I'm going to highlight, matches with what I highlighted here? That the boundaries are at 1 and 4, and I only want the portion of the graph where the x values are between those 2 things. Okay? And we'll deal with endpoints in a minute. Okay. All right, on the third graph, it was a constant function. So I have a straight line. I know, I drew it, so it's not that straight. But I have a constant function going across at 1.5. Okay, so all of these points have a y-coordinate of 1.5. They formed this line. That's why my line looks like that. Y is always 1.5. I want to highlight in that graph the portion where the domain is x greater than or equal to 4. Okay, so again, how do I understand that? I'm understanding that as I want to identify where this boundary is of 4, and I only want to use the portion of the line that would contain points where the x value was greater than or equal to 4. So this portion of the line. Is this okay with everybody? So basically our skill checks here. Can we graph lines if they're written basically in slope-intercept form? Do we understand what someone is asking us when they're saying a domain of this information here, that it's just a piece of that function? Now the endpoints. I was really loose in Desmos about like, oh, I don't care if you wrote less or less than or equal to or something like that, right? But it matters if points are contained on our graph or not. When I say something like between 1 and 4 right here, am I just going up to 4? Am I actually including the point that has the x value of 4? So we have to go back and read the inequalities more carefully, okay? So look at your inequalities. The first one said x was less than 1. Does that let x equal 1?
No.
No. But should I go all the way up to 1? Yes. Then what number am I stopping at?
Well, it goes up to infinity.
Right. It's a really confusing question in math. It's super weird, right? You can pick any two numbers, and how many numbers are in between them? An infinite amount, right? It's weird because you can keep adding on all those decimals and random things like that. So how do I indicate that I'm going up to 1 but not equaling 1? I can't tell you where to stop. The best way I can describe it is go all the way up to 1 but never hit 1. And the way we do that graphically is with that open point, right? So if I put an open point on that endpoint, that's telling someone, yes, it goes all the way up to the point where this function had an x value of 1, but it doesn't actually include that point. But everything before it. That's the best way I can say it, because I can't tell you what's right before it because there's infinite amount of things, right? It's kind of strange. The second set of domain restrictions for the second equation we had up here was that we want x between 1 and 4, but we are including 1 this time. Do you guys see the difference and why we're including 1 because of this equal to in the inequality? Not only is 1 an endpoint on this one, but it's an included endpoint. 4 is an endpoint, but are we including 4? No. So this would look like this. At 1, that endpoint is filled in, and then we want all these points in between, but when we get to 4, we just want to go up to 4, but not include it, so it's an open point again, okay? So at 4, I know the black is hard to see with the red, but I drew an open point here. Open, okay? And so then lastly, when we look at the third restriction on this third graph, it said that 4 was the only boundary and we wanted everything larger than 4. But it does say to also include 4. So where we're cutting it off at that boundary, that highlighted portion, that endpoint is going to be filled in because we are including it. So are they going to do, you guys have seen math work, right? Do you think they write this all out every time they want you to write a piecewise function? Do you think they give you the 3 separate equations and they write these instructions? No way, right? There's notation for everything, right? Everything is shortened into some notation. So how do they write this shorter? What you see below this. Everything we just did is said in this one equation. How do you know it's only one graph? Because how many equations are there up here? There's really just only one. See the 1 equal sign right here? But that equation has been split into how many pieces? 3. So you know that you're writing one graph, but that graph is going to have 3 parts. How are you going to graph it? Well, there's a couple of options. Option 1 is what we just did. Graph everything separately and highlight the part that you want, and then put that together. Option 2, use the endpoints. When I read this equation and I see that this is an endpoint, that has to be a stopping point, right? Plug 1 in, as if I were making a little XY table for this point. What happens when I plug 1 into that equation? 2 times 1 is 2, plus 1 is 3. Now I know that 1 comma 3 is the exact stopping point I want for that first portion of the graph, right? I'm going to graph that 1 comma 3 with an open point. And then I want to graph the rest of the line. I think honestly the easiest way to do it if you're going to use this approach is plug in another point, but make sure you're in the domain, right? Where do we want to graph this line? We want to graph it when x is less than 1. So if you're going to pick a number to plug in, what kind of number should you pick? Something that is less than 1. Is everybody on board with why we'd want to pick that? We only want a certain portion of the line. Make sure you're using the right piece. So let's say I plug in 0. 0 is really nice, right? Okay, so if I plug in 0 for this one, I choose 0. 2 times 0 is 0, plus 1 is 1. I get the point 0, 1. For a line, 2 points are enough to draw a line, right? It doesn't curve or anything, so I have the shape that I need here. That matches the highlighting thing we just did. Yes, sir?
If we draw a dot there and it's one less than or equal to it anyway, then how are we going to show that's filled in? Or do we just fill it in anyway?
If it said less than or equal to, we would fill it in. When the next one overlaps it, then we just draw it filled in, and they don't need to know which piece it came from. Does that address your question? Okay. Was that the same question that was coming up over here? All right, so the next line, right? I can either do what I did, graph it, erase the parts I don't need, or highlight the parts I want and put that onto my graph, or I can plug in points. If it's a line and you have 2 points, you can literally just plug in those 2 points to get the information you need. When I plug in 1, I have -1/2 plus 7/2 is 6/2 or 3. So this segment is going to have 1, 3 as one of the endpoints, and it's going to be drawn and connected to the next segment, which when I plug in 4, -1/2 times 4 is -4/2 plus 7/2 is 3/2, or 1.5. I'm going to draw those 2 points. Now, this was the question that was just asked. Well, the next one ended up at the same place that this one did, right? 1, 3, 1, 3. But this time it's filled in. What do? Well, if you weren't including it, but now there's a point that landed in the same place, then overall in your graph, it got included, right? Eventually. It doesn't matter when. Your graph just has to show that it was. So this is now a filled in point and no longer an open point because this graph happened to overlap at that endpoint. And then it continues to the point 4, 1.5. So 1, 2, 3, 4, 1.5, and that one is an open endpoint. Okay. And then for my last line, it seems kind of silly to even do this chart just because it's horizontal, but in case you forgot that, again, I could start with the endpoint, which I see is at 4. When I plug in 4, what do I get? I'm always going to get 1.5. It's that constant function. It doesn't matter what I plug in, I'm getting 1.5. What other points do I want to know? I want x values that are bigger than or equal to 4. So if let's say I pick 6. Okay? But again, this is a constant function. When you plug in 6, what do I get? Same outcome as before, 1.5. This happens again to overlap the previous point. So before we drew the point 4, 1.5 not included in the graph, but now we found something that does include it, then overall that point is just now part of our graph because it got overlapped with a point that we were graphing. Okay? And then here's 6, 4.5, and because my line keeps going and can plug in anything greater than 4, I have the arrows on the ends. Little different than Amy's trip. She had beginning and end points, right? Okay. All right, does everybody feel like if you were presented with an equation like this, you now understand what that equation means, and you have a strategy to get that equation onto a graph? Okay, whether it's I graph them separately and highlight, I draw them on the graph and erase the parts I don't need like we did on Desmos with Amy's, or I use this little plugging in technique and I get the different pieces. Will they always overlap and connect here?
No.
No, that was just a characteristic of this specific equation that they happened to connect, okay? The fact that they did connect, though, gives us an answer to some of these questions over here, okay? We talked about this with your summer packet. Is this function continuous? Can you draw this function without having to skip any points or lift up your pencil from left to right? Yes, okay? Will a piecewise function always be continuous?
No. Wait. No.
No, this is actually a repeat of the question I just asked you, right? I'm just now using a lot of math vocabulary. Before I said, oh, will all these points always connect to each other? And we said, oh, no. Now I'm saying it in a mathy way. Will the piecewise function always be continuous? No. Okay, meaning sometimes if this wasn't at 1.5, let's say they graphed it at 5, this little branch would have been up here. Okay? So this could have looked like this. If I just change that value to like 5 or something like that. Okay? So they might not connect at all. All right, other question, is this actually a function? So it's a piecewise graph. Does it meet that special definition of being a function? How do we test for a function? Who has a way that we can test? Yes? Good. Okay, vertical line test. We're testing essentially that every x only has one y value that corresponds to it, and this meets the requirement, right? Now be careful, would this one meet the requirement?
Yes.
All right, mixed bag, yes. So here's the vertical line where I'm concerned when I'm running the test, right? And I feel like it's failing because it looks like it's hitting my graph twice. But when I look a little closer, yes, it's hitting my graph right here. Is it technically hitting my graph right here? No, that point is not included. So there is still technically only one y for that x. This is just indicating that I don't go past that point, right? A little bit tricky, okay? All right, next portion of this, we want to talk about domain and range, okay? So two ways that we can do domain. Visually and algebraically, and you might not like piecewise functions, but I'm going to tell you this, as far as finding their domain, it pretty much rocks because they wrote all this stuff for you right here, which were domain restrictions, right? So they're basically listing all the x's that are part of the domain. The main thing is you have to understand this is one function put together, okay? So we'll do it both ways. So first, algebraically. The first equation says we use this when x is less than 1. So if we only used this first one, if that was the only thing we wrote, our domain would be that x has to be less than 1. Is that okay with everybody? But we put a second piece into this function. So you can't just use the x that's less than 1. You have to also use this next part, okay? What is the next part saying? The next part is saying x can equal 1 and be bigger than 1 all the way up until 4. So if we're only using these two, okay, our domain would be that x is less than 4. Are you guys with me on that? Like we had less than 1 and then we included 1 and everything up to 4. So all together now we can use any x that's less than 4 for those two pieces. But then we put a third piece into the function, okay? So this third piece then says, not only can x be all those things that we said before, but now x can be equal to 4, and it can be bigger than 4. Which means by the time we've looked at all three pieces, what values of x are we allowed to use in this function?
All real numbers.
Are you guys with Richard? Did you guys hear what he said? All real numbers, okay? If you don't like the algebraically, look at the visual. Look at the picture of the graph. If you go as far left as you can you pick out any x that doesn't have a piece of graph that will correspond to it? Let's say I go way out to -10. Will -10 match up with a point on my graph? It will, right? Okay, because this is forever going this way. This has a point, this has a point, 0 has a point, 1 has a point. Because it's continuous and it doesn't ever end, that means it never ended and I never skipped anything. Every x from left or right, I could pick one and find a point that matches with it on the graph. Is that okay with everybody? All right, so domain, all real numbers. You guys can write it down. I'm going to use that fun set notation. It's a bold capital R when you don't have a computer. Okay, that's typing for you. Yeah, basically. I just draw 2 lines at my R and then make it that way. Okay? It's not IR, it is an R, but the R has 2 lines here. This is set notation in math. That R with 2 lines means all real numbers. If they just drew a regular R, you wouldn't know that. In your book, it'll be like bold and capital and have like a little more curve to it, okay? All right, the range is a little bit more difficult, okay? You can visually see it on this graph pretty well. And if you're struggling with it, I'll give you a way to look at it as well. So I'm gonna give you the struggling. A lot of you guys are looking at it right now and you already know what the range is. We're basically gonna do what we just did for domain, but instead of thinking horizontally, we're gonna think vertically, okay? I'm gonna do it in pieces for those of you that struggle a little bit with it, okay? And if you struggle, here's what I basically want you to think for range. And I'm sorry, we did answer yes to this function question. All right, so for range, if you have to, look at it piece by piece. So I'm going to look at the first piece. According to the graph, not according to the equation. If I looked just at that piece, the range is, there is a maximum it reaches, but there is no minimum. Is that okay with everybody? So my range so far is something that y meets this one thing and is everything below it. So I'm going to use like this, like a little number line over here. This will help us later when we're doing some other things, and when the piecewise functions aren't all connected, this is a pretty good method to do. The first piece, the maximum it reached was up here at 3. So far, I would say my range is hits at 3 and goes below 3. Just looking at that one piece. Is that okay with everybody? That with that one piece vertically, that's what I see as like the max, min, when I'm looking at the vertical numbers that it reaches. Now I look at the second piece, okay? The second piece here goes from here to here. Remember, our goal is to think vertical. So this first point up here is still at 3. The other point here is at 1.5. So the segment that I've marked in green, its range is in between 3 and 1.5. And they're covered in the graph. Again, I'm not going by the equation. I'm just looking at what ended up in the picture. So if I had to mark that, somewhere here is 1.5 and the green's in there. It was already covered by the blue. So was it really that important that I marked it? No, but could it be if your pieces were moved all around on the graph? It could be. So this is why I'm showing you this method, okay? Third and final piece, when I look at that piece. So this piece is here at 1.5 and continues to the right, but y value wise, all of those points just stay at 1.5, right? Which is kind of weird. That means the range for that one piece is just the number 1.5. That is the only y value it ever reaches. So it just hits this point again. Overall, my range is going to be whatever this number line is now saying. Okay, and this number line with all the ranges stacked on top of each other to see all the different y values I hit, overall, if I just summarize it, it is basically saying this is the max, and it covers everything below that. And it does hit that point. Okay, so my range is that the y values are less than or equal to 3. And again, you probably could have saw that with the graph, but if you break those pieces apart, it's going to get more difficult. So I'm giving you a second strategy to visually see all the numbers you're hitting. Okay? All right, so not too different from maybe algebra 1-ish, okay, a little step forward, but we're going to add something to it, which is notation. So in this class, you have to use a different notation. So we'll show you when you have to use it, but we're going to start using it right now. This is called sometimes like set notation. There's a more specific set notation when you write this. These are inequalities. We want to show you guys interval notation. So off to the side, I want you guys to make a note about interval notation. Sorry, that's an I. So this is intervals, okay? An interval tells somebody a minimum number. So this is not a hashtag. I'm using that to mean the symbol number, okay? I know your generation, it's hashtag. For like the rotary phones, it was pound. For some of us, it's only meant number. So, and then a maximum number. Just by writing these next to each other with a comma in between, instead of saying x is between 1 and 4, you just write 1, 4. But then I have to know if I'm allowed to be equal to 1 or not, and if I'm allowed to be equal to 4 or not. So these are surrounded by some sort of parentheses or brackets, and I'll show you what they look like. So you could be using something like this, or you could be using something like this. And it could be a mix of the two. There could be 2 brackets, there could be 2 parentheses, there could be one of this and one of this in either way. So how do we know? What's the difference? If you're using a parenthesis, sorry, this little bar is right in the way. All right, if we're using a parenthesis, that means not equal. okay? If you're using the square bracket, that means equal to. Okay, so square bracket means you go up to and include that number. Parenthesis means you're not including it, okay? So for example, let's say I wanted x to be between 5 and -3, okay? To put together something like this, you look at this and you say, what's the smallest number x can be? -3. Comma, what's the biggest number x can be? 5. Now it needs to be enclosed in the notation. Is x allowed to equal -3? No. So I use a parenthesis. Is x allowed to equal 5? Yes. Then that side is enclosed with a bracket. This notation tells me that whatever you're talking about, in this case x's, go from -3 to 5, where we don't include -3, but we do include 5. Is that okay with everybody? So we're going to go back and do our domain and range the same way. And I'll see if I answer your question. Save it, Richard, and if I don't, you'll ask it right after we're done with this, okay? So, when we look at the domain, it says all real numbers. We're now going to write it in interval notation, okay? So I'm just going to put a little or between here. You can write it like that, or you can write it like this. But when I say or, don't be like, oh, I don't have to learn this. She just said or. No. Every time we do something, there is one specific thing, we're not there yet, that we're going to make you use interval notation for. It's part of our class. We have to make sure you learn what it is, okay? So all real numbers. What's the minimum value?
There is no minimum.
There is no minimum value. How do you guys think we're going to represent that? Okay, so infinitely, but the lowest. -infinity is how we represent that. So when there is no minimum, you want to tell me I can get infinitely lower. The way you do that mathematically is you use a -infinity symbol. Okay? What is the maximum value? Good job, Richard. I hear Richard. I'm making sure the rest of us know. What is the maximum value? There isn't one, right? So we say infinity, but in the positive version, so we know it's going upward rather than downward. Okay. Now, do I put parentheses or brackets? This is a little tricky. Remember how we decided over here? Because I could reach 5 and be 5, I put a bracket. Can you reach infinity? So because infinity is more of a mathematical idea and not a value, it doesn't make sense for us to put a square bracket, because that means you get to infinity and you plug infinity in and you use that and then you don't go any further. That doesn't make sense, right? I know it's weird because you're like, but it's everything. Like we should have the brackets, like we're including things. But infinity is more of an idea than a number, since it can't actually be reached. Every time you use an infinity or a negative infinity, you'll automatically be using a parenthesis because you cannot reach that number. Does that make sense to everybody? It is not a number. That doesn't make sense. It is really an idea that it continues, okay? All right, so let's try y is less than or equal to 3. What does that look like in interval notation, okay? So, right, or, meaning this is another way to write this, but you do have to learn interval notation, right? And remember how we do this. I want to list the minimum value and the maximum value, and then I want to analyze whether I need to include a bracket to represent equality to that number, okay? What is the minimum value for y if y is less than or equal to 3? Good. There is no minimum value, therefore, negative infinity. Right? What is the maximum value for y? The highest y can be is 3, right? That's the limitation on this inequality. So our boundaries are from negative infinity to 3. What kind of enclosure are we using on the negative infinity side? Parenthesis or bracket? Parenthesis. Always a parenthesis with our infinities, right? What about with the 3? Bracket, because this inequality doesn't say y is less than 3. It says that y can also equal 3, we want to make sure it's included in there. We're not going up to 3, we're going up to and including 3. Okay? All right. Questions?